Okay, hi. This is just going to be a real quick kind of introduction to using the setup for the Gaussian computational cluster that we have. So I'll be happy to give a tutorial or training for people like over Zoom, or if we need to, we could do some small sessions maybe with some people or something like that. So let me know. But I just want to give you kind of the basics in this video. So I'll go through all these probably relatively quickly. So I mostly want to get down and show you the basics of how you log in and submit Gaussian jobs, okay? So that once I give you an account, you can go ahead and get on and start working, okay? So we're using a new technology called Guacamole, which allows us to serve desktops and other kinds of connections over a regular web interface, so over a web browser, right? This video I'm going to make private. So at the moment, I'll give you this link here in the email when I create an account for you. So basically, though, you'll have to go to a particular port number, and then you have to do /guacamole. So it's on the TLC hardware.pro. TLC stands for the Lion Cloud, or the TAMUC Lion Cloud here. So I have set up a demo user called Gaussian, Gaussian, with the password the same. So before I give you an account, you can go ahead and jump into this. Although I think the way that the remote desktop server here works is that it only will allow one person at a time on there. So if you're on, it might kick you off if somebody else logs in. So anyway. I'll give you a username or password, or you could try some out, try and train yourself on the Gaussian. So once you get in, I've got everything set up so you don't need a password or username anymore. So there's two basic things that you can get to. So you can get to a plain terminal, secure shell terminal from here, or you can get to a full remote desktop from here. So most of the stuff that you want to do on the cluster should be just submitting jobs to the batch queue, right? So you shouldn't really be doing stuff with Gauss view or things like that. Oh, and by the way, I've set up also a virtual box so that we can actually install basically the same environment on your own computer. So the same virtual machine on your own laptop. So that's really probably the way that you should be using Gauss view and things. So here, mostly we're going to be looking at how to use the compute cluster to submit jobs. Okay, so you really want to be using this. So if you click on the secure shell, you get a basic terminal interface. Okay, and you'll want to know. I forgot to clean those off. So you'll want to know, maybe learn a little bit that's beyond the scope of this video, but some basic command line, Linux command line commands, so like ls to list your directory contents, and cd to change directories, and so on, okay? But yeah, this is a basic terminal interface, okay? And this will allow you to get full access to be able to submit jobs and things like that, so if you want to. And this should be relatively fast no matter where you're at, just to use the basic terminal here, okay? So one command you do need to know for this Guacamole interface is the Control-Alt-Shift key. So if you want to bring back up the menu so you can interact with this Guacamole technology, this Guacamole server, so that's Control-Alt-Shift again, so hit those three keys, and this will bring up, this is basically the interface for the Guacamole. So in essence, you need that in order to use the file transfer protocol, and I'll talk about that real quickly in just a second, and also to get back to your home screen, so if you want to go to a different connection, okay? And by the way, if you want to have multiple secure shell connections, you can, although if you click on this, it'll take you back to the same one, so it'll only have one at a time, but you can just open up another terminal and navigate. So I would recommend like maybe putting a hot link or something to that, so you don't have to type those in. But if you navigate to that again, then you'll have a different secure shell interface in here, so you can run secure shell. So you can have multiple secure shells open like that by using multiple tabs in your browser. Okay, so so then let me show you the other connection that you can use. So we've got a full remote desktop using the RDP protocol here. So if you click on that, that should bring up the remote desktop protocol. So I'm going to make this terminal a little bit smaller. Oops. No, I wanted. There we go. So this is a basic lightweight Unix Linux desktop called XFCE. So I mean, of course, I'm on a really slow connection here at my home connection, so I tend to only get, you know, maybe 100, 500 K. I'm lucky if I'm getting a mega bit per second. So, but you know, it's still pretty usable, even the GUI interface. Okay, so. Let me go over to a different desktop. I'll put some good reference documentation and some links to useful programs. I might try and add some more here. At the moment, I've got Gaussian and GaussView, and I've also got the GAMS installed that people could try out if you're interested. And I've got this MacBoplot, which looks like it's a analog to Gaussian, right? To GaussView. But you can double click on these or click down here to start off GaussView. But like I said, you really shouldn't be using GaussView from here. If you're mostly interested in using GaussView, let me know, and I will set up basically the same virtual environment but on your computer. Okay, so I've got a virtual box set up for this so that we can use that. And that's really the real way that you should be using, like, GaussView. So your workflow probably should be, you know, use GaussView on your local computer to set up a job, and then you would jump over to our Gauss compute cluster here to submit a big calculation, basically, right? So anyway, I'm not an expert in using Gaussian, so you can, I think maybe you can talk with Lawrence or some other people know kind of more about using GaussView and Gaussian to do things. But we do have this available here. So like I said, I'm mostly going to show you just how to submit compute jobs on here. I've got a little reference, kind of a reminder of kind of the commands that you can use. A little word about our cluster. So this cluster I've got set up right now has 8 compute nodes and 1 server node. So it has compute nodes numbered 1 through 9, or well, the compute nodes are 2 through 9 basically, and Gauss 01 is the server. Okay, so one basic thing you can do, you can SSH over to a different compute node, and then you could start a job by hand, like for example using G09 serial. So this will run a job just on a single compute node, right? So I could submit, let's say, experiment10.com. Okay. So this is actually running on Gauss 02, but you really shouldn't be submitting jobs by hand like this. And then this one is a relatively small job, so the result is a log file. So again, you can maybe get with Lawrence or somebody who's more of an expert on using Gaussian. So, but this should be a standard result file that you get from running this. And you can get checkpoint files as well. Okay, but like I was saying, so you can do that, but you should mostly use that only if you're having some problems or emergency. I mostly use that to debug things. Okay, so let me show you using the cluster then. So yeah, you normally shouldn't be using G09 serial or G09 parallel. They're mostly there for testing. So what we have set up on this Gaussian compute cluster is what's known as a batching system or a resource management system. Okay, so basically the way this works, so a simple thing that you can do is you can use the qsub command to submit basically a shell script. So here's an example of a qsub shell script that I'll just show you real quickly. Okay, so if you know anything about creating shell scripts in Unix, this is just a regular shell script. So these are the same as running. I could run these same commands from the command line, and they would all work. And I'll show you that here in a second. There are some special things here. So these things with the pound PBS are actually directives to the torque portable batching system. PBS stands for portable batching system. So my job is going to be named this. So here, this is an important one. So these are the resources. I just want one node and one processor per node. Okay. So these are not using any parallelism. It just uses a single CPU on a single node here. But as I'll show here for the Gaussian jobs, you can do you can request multiple nodes or multiple processors on each node that you request. Okay. So a basic submission, before I do that, so this little calculation will calculate digits of pi. So if I ask to calculate 10 digits of pi, it'll do that, okay? So a little bit of, maybe before I did this, I should have shown you. So if I wanted to submit a single job, in this case, this job takes a command line parameter, so I can use the -F option to give command line parameters. So let's say if I want to calculate 100 digits of pi, I could do that and say, then submit this calc_pi dot q sub. Right? I have to spell it correctly though. So then another command I'll show you is qstat. So qstat will give a basic queue status. So right now it's actually completed already. So it submitted this job. It ran it on Gauss 02. So it actually ran it on the compute cluster node 2 here using CPU 0. So the CPUs are numbered 0 to 15. There's 16 CPUs. So I should have mentioned that. So you've got 8 right now. You've got 8 compute nodes, and each compute node has 16 CPUs. So you have a total of 128 possible CPU resources that you can use. And I can expand this if we need to and things. Okay. So if you look at your directory listing, whenever you run one of these, you'll end up with one of these .o files. So that actually had the standard output from running the job here. So if I cat that out, I can see my presumably 100 digits of pi with some other information. Okay. So if I wanted to, I could submit like 32 of these jobs, for example. All of these will calculate 10,000 digits of pi, but as you can see, I could do something more sophisticated. So the normal way I use a batching system like this, I often do things like this, submitting lots of jobs, but all of them might have some different parameters because I want them all to compute slightly different things for an experiment or something like that, for example. So alright, so that'll submit 32 jobs basically to calculate 10,000 digits of pi. So another command you can use is qmon, which basically just does a qstat in a loop. So every 5 seconds it calls qstat, and we can see all of the running jobs on the cluster here. So some of the things on this output. So in this case, again, all these jobs just requested one single node and one CPU. I don't know exactly what TSK stands for, but this is the number of CPUs for each of these jobs. And as you can see, usually if nodes are free, it just assigns them starting at node 2. So this first job, everything's completed now, but this first job started on Gauss 2, CPU 0, and then the next one on Gauss 2, CPU 1, and so on. Okay. And that was so these all completed. These all completed their task of calculating 10,000 digits of pi, and then I end up with all the output files here. So for example, if I want to see the output for this last one, I can do that. Right? So there's my 10,000 digits of pi here. All right. So I've shown you, I've shown you most of these commands here in this reference, except for the G09Q sub. So this, as a Gaussian user, this will be the main one that you want to use. So mainly the G09Q sub just takes one of these Gaussian.com files, and it takes an optional second parameter. So if you want to run a true parallel job, you can specify that I want to run it on more than one compute node using this. Okay, so let me remove all these here, these output results. So I've got a couple of com files here. So let's say I want to submit my experiment 1. All right. So again, if you don't specify anything, it'll run it on one compute node. But by default, the G09Q sub runs the job on a single node, but using all of the CPUs on that node. So it'll use 16 CPUs. Okay. So from my experience, Gaussian works best using what's known as shared memory parallelism. So just using all the CPUs on a single node. And then it passes information back and forth within the memory on that node. Okay, so let's submit experiment 1 using a single node and experiment 2 using a single node. Oops, like that. So you'll see now that the experiment 1 and 2 are running. These will take about 2 minutes or so. So, but notice each one of these is running on a single node with 16 CPU resources. Okay, so you see that the experiment 1 is running on Gauss 2 and experiment 2 is running on Gauss 3 here. Okay. Now you can do message passing parallelism as well. So if I want to maybe run experiment 3, let's have it run on 2 nodes. I can do that. So it runs on 2 nodes. So now experiment 3 is running. 1 and 2 are still running. They've been running for 45 seconds. And experiment 3 started off on my screen wrapped a little bit here. Make this a little bit bigger. So there you can see it's actually running on Gauss 4 and Gauss 5 using all 16 CPUs on both of those. Okay. And I'll do experiment 4 as a 2-node job, and maybe experiment 5 will be a 4-node one, and you've got 8 nodes at total, so the most you can use is like 8 nodes, so maybe experiment 6 is 8 nodes. Although, again, let me emphasize, from my experience, and maybe Lawrence would be able to talk about this as well, but the message passing parallelism does not work on Gaussian except for very specific kinds of jobs, so mostly you do not really want to be doing this unless you've done some experiments and found out that it actually helps. So usually for most Gaussian jobs, you won't get any faster results, and they might even be a little bit slower usually than if you just run it on a single node using all 16 CPUs. That's because the overhead of passing the information between nodes outweighs the speed up you get from using more than 16 CPUs usually. Okay, but this is just for demonstration purposes. So I'll do experiment 6 on all 8 nodes, and then experiment 7, 8, and 9 are all just single node experiments again, we'll say. All right, and let's bring up the QMon to look at that. So right now I've got some of the ones that I ran completed now, so my experiment 1 and 2 have now completed. That's what the C means here. Also experiment 3 that I ran on 2 nodes has completed at this point. Experiment 4 and 5 are now running. So 4 is running on 2 nodes. Experiment 5 is running on 4 nodes, so it's running on compute node 9, 8, 3, and 2. All right, and some things are completing off now here. So once jobs complete off, they stop showing up on the QStat output after a bit here. So, okay. So, like I said, I didn't want to go too long on this video. So those are the basics, and so you mostly, as I just showed, want to be, this is the main command that you want to use, is the G09 sub to submit jobs, and then you want to use qstat or qmon to be able to look at the batch queue, the status of your jobs and how they're doing on there. Okay. Whenever you run a job like this, you'll get these .output files, but your actual real output will end up in a .log file. So again, this is another Gaussian thing. So when you compute a Gaussian job, the .com is the input, and it just gives a .log file, but this has all your results. Okay, so for all of these, my resulting output is going to be in them with the same name as the .com file, but with a .log extension. Okay. Oh, and I forgot to show file transfer. Okay, so if you want to get com files on or log files back off of here, we do have file transfer set up using that guacamole. So again, if you use Control-Alt-Shift, that'll bring up the guacamole interface, and then here, if you click on here, this is your file transfer interface. So if I want to, if I double click on like a file like a log file, so double clicking on this will allow me to save it. This will save it back down to my local computer here, right? And if you want to, you can upload a file, or I found out you can actually drag and drop files. So if I take a file from over here, like this file, and drag it on here, it'll upload it basically onto your home directory. Okay. All right, so that's the basic thing. And if you want to close off this guacamole, so it's the Control-Shift-Off basically toggles Control-Shift-Alt toggles that panel to access the guacamole. Okay. All right, so that's basically it here. We covered most all these things. All right, so you can get basic terminal connections, or you can use a remote desktop. Remember the Control-Alt-Shift key to get access to the guacamole, so you can do file transfers and things like that. And your main thing that you want to use is the G09 qsub command when you're using this compute cluster. Okay, that's it for this video, and I shall see you guys around then.